Hi everyone, and welcome to already our fourth edition of the Dutch Cloud Meetup, and especially the Cloud Takeaways. Today we have a special guest already between us with a very interesting session. But first, let us take you through the first introductions of our team. So basically, the Dutch Cloud Meetup is larger than only me, but I'm one of the main founders of the Cloud Takeaways. So I will be hosting the session today with you. I'm Mike van Graag. I work for 350, a consultancy company in the Netherlands, and I'm also a Microsoft MVP. And especially without our sponsors, we could not be here. So at this moment, we have four sponsors. We have Betabit in the Netherlands, SPS, 350, and Brink Software. So a special thanks to our sponsors for sponsoring our events, and in the future also sponsoring our on-premise events as well. So we are really looking forward to go to locations of our sponsors and really have the in-person sessions that we would like to have as well with all our participants of the group. So basically this session will be live streamed on multiple locations. So we are streaming live from LinkedIn, YouTube, and also from Twitter. If you have any questions, remarks, comments, or anything you can think of that you would like to share with the group, you can share that within the comments of the specified platforms. Questions will be raised to the speaker at the end of the session, so that we can also have a small discussion around it and how everything all works. So that really leaves me on welcoming Leo into the stream because he will have the time for his session, Level Up Your Azure DevOps Pipeline. So hi Leo, how are you doing?
Hi, Mark. I'm doing fine. You too?
Great. Are you ready for your session?
I think I'm completely ready. I hope the audience is too.
Okay, yeah, I think the audience will be ready as well. So let me stop sharing my slides and let me add your desktop to the stream. And then the
Yes,
floor is yours.
thank you very much. So, welcome everybody to level up your Azure DevOps pipelines. In this presentation, I will tell you something about my experience with Azure DevOps pipelines. But first, a small introduction of who I am. I'm Leo Visser. I'm a cloud consultant at OGD. We're a company in the whole of the Netherlands, and I mostly work with infrastructure as code, CI/CD, automation, some DevOps practices. In the past, I've done several different things. And if you want to know more about me, I've got a blog, autosysops.com, or you can find me on Twitter. During this presentation, I'm going to quickly tell you about what Azure DevOps pipelines actually are. We're going to look a little bit at templates, and then I'm going to go into the nice things which I want to share with you, the automatic retry, using of approvals, parallelization, and finally some automatic rollback. I hope everything will work. There's a lot of demos in the presentation. I've tested them all, but you will always see something will go wrong. So let's quickly go into the Azure DevOps Pipelines introduction. I hope most of you know what a pipeline is, but just in case you don't know, we have this platform called Azure DevOps. It's provided by Microsoft. The name Azure kind of gave it away. And one of the things in Azure DevOps is the pipeline possibility. With pipeline, we can utilize some compute resources to, for example, package applications or to deploy resources or to perform other different tasks. Azure DevOps is like a source control program, so kind of like GitHub. Lately, GitHub also has the GitHub Actions, which is kind of the same as the Azure DevOps pipelines. These pipelines, they're not like uh, really automation things per se. They're like acute execution. So you can drop a lot of requests in it, and they will slowly churn through all the requests. So you don't want to use this for things which, for example, are time sensitive. if you need to do something right now, pipelines might not be the best option to do. The pipelines also run on agents, and there's like two different types of agents. You can have self-hosted agents or agents hosted by Microsoft, and these agents will process the different things you will ask. In Azure DevOps, in the past, we had release pipelines and build pipelines. Nowadays, it's just called pipelines and releases. During this overview, during this presentation, I will only talk about the build pipelines, or which is now just called pipelines. So the pipelines, they're written in YAML. YAML stands for YAML ain't a markup language. It's a way to store data. Some people might know JSON. JSON is like the same idea. It's a markup language, or it's not a markup language to store data. Azure DevOps uses this format to define the pipelines and to determine what's going to happen. So the syntax is quite specific for Azure DevOps. All the pipelines are stored in source control, so you can easily um, put checks on it and and go back to previous versions and so on. And there's a whole marketplace of different tasks you can use in your pipelines. In Azure DevOps, after you've created the YAML file, you still have to set it up so it will actually run. And in Azure DevOps, you can also look at logs and check other things. YAML files will be compiled. A lot of the times this means that they are quite the same, but there's things we're going to look at which are actually compiled. So before the file is sent to the agent, Azure DevOps will first compile it so this can be sent. This is important to know because there are different steps on where things happen. So some things happen in the compile stage, some things happen when a task starts, and some things happen during runtime itself. And we will look at these different things and how to utilize them. And let's quickly get into templates because I want to have a lot of time for the actual demos. Templates are a useful thing you can use. I'm not going to show them that much. We're going to mostly look at some of the other tips and tricks. But with templates, I can split up a YAML file into different pieces. So I have one YAML file where I can ask for different pieces. If you, for example, worked with Bicep, they're like modules. If you work with ARM templates, you can also import different linked ARM templates. You can see this as the same way. You can write different YAML files and import them. And when they're compiled, they're merged together. And this way you can reuse some of your YAML files. So for example, if you made a template part to run different tests, you can use this template in different pipelines which all have to run these tests. For example, there's many different ways to use templates. One important thing to note is that templates also have parameters. So you can have parameters sent to the template, but like I said, they're compiled into one big YAML file before being sent to the agent. So most of the times, templates will also be aware of parameters defined in higher levels in your YAML file. This is something to keep an eye out for because sometimes it happens that you might reuse variable names, and this could cause a lot of weird things. I've seen this happen in practice, and it's not fun to troubleshoot what's happening there. One last thing, templates have something called template expressions, and a lot of things you can also use in normal YAML files, but there's expressions like each, which are specific for templates. With each, you can take a object which has multiple entries or um, attributes, and do a certain step for every of the attributes. We're going to look at some other ways of parallelization in the basic YAML files later on, but note that there's also this way of using templates in each. It also has a lot of restrictions because you have to send the things in the parameter, and this will all be done at compile time. So if you're using the each expression, you really need to know how many things there are already and which things are going to happen. And we're going to look at a way later how you can do this without knowing what's going to happen or how many things are going to happen. So that's the very quick 101 about Azure DevOps pipelines. Now let's go into some of the tips and tricks I've gathered over the last few years working with these pipelines. Keeping an eye out for the new developments. And one of the developments I saw a couple of months ago, which made me very happy, was this, the retry count on task failure option. In the past, if your task failed, your task just failed, and you could try to build in some logic with an extra task, trying to rerun it. But most of the times, the pipelines just assumed your task would always complete or fail, and it wouldn't have these tasks which sometimes failed, but most of the times work. Everyone who works with APIs know that sometimes an API just doesn't work. So having this option is quite handy for some specific purposes. What you can do with this is you can just add one line and define how many times a task will be retried before it actually fails. There's an incremental backoff built in already, so it won't just try it like 10 times with a second in between, but the time in between the retries will slowly increase. You can see the different retries in the logs, and eventually it will still show as failed or completed if after a couple of retries it will work. On the right side, you see a small script I've made, which will always fail a few times before it will actually go through. For the people who are not familiar with PowerShell, I will quickly explain it. So I check if there's a count.dat file present on my agent. If it is, it will take the content and make it into a number, an integer. If not, it will just set the number on 0. And I'm going to increment the number with 1 and send it back to the file. And if the number is lower than 3, it will just throw, so it will error saying not enough entries. So normally speaking, this should run the first time, create a file with a 1 in it, run the second time, create a file with a 2 in it, run the third time, and the third time it should see that count is still 2 because we're only incrementing it here to the file. So still fail, and then the fourth time it should work. It can retry it a maximum of 10 times. So if something still goes wrong, eventually it will fail. And now let's see if we can get the demo to work. So I'm going to share a different screen now. Let's see where it is. This one. Yes. So here we are in Azure DevOps. I've got my own project, my pipeline project. I've got several different repositories. And the first one we're going to look at is the retry logic. And here we have this same pipeline again. So there's a trigger in the pipeline, which at the moment is just none. So I can trigger it manually. I run it on a pool, which is called Azure VM. That means that it's running on my self-hosted agent. I'm mostly doing this at the moment to make sure it always works and I'm not waiting in the queue on the Microsoft hosted agents. Sometimes when doing a presentation at busy hours, it can happen that you have to wait 5 or 10 minutes before the job executes. This way, I at least know how big the queue will be. And here we see the same script you saw before in the presentation. So if I go to the pipelines, we will see the same pipeline here, the retry logic. And I can actually run it. When running it, I'll enter up in this window and here we'll see the job, which is at the moment queued and should start any minute. So it's starting now. And here we've seen that it says retry 0, no file found, and it's exited. The next time we have retry 1, the file is now found, retry 2, and you see that it's taking a little bit longer already, and now it was completed. So let's go back. So in orange, it also says the next attempt will be after 1000 milliseconds, after 4000 milliseconds, after 9000 milliseconds. And the last one, you see retry 3, it was completed. So by using this retry task, I can make something which is a little bit flaky still work in my pipeline. You'll see we still have the errors showing here and the warnings in the logs. So I can still see something went wrong, but overall my pipeline did complete successfully. So I can look at it later, but I know it worked. Let's get back to the presentation again. I'm not seeing the presentation on screen. I am sharing it. Yeah, there it is. Thank you. So next up, I want to talk a little bit about approvals. When creating pipelines, it's often very nice to be able to build in approvals. For example, sometimes you use pipelines to deploy like different resources to different environments. One of the customers I worked with, we were deploying several different Azure infrastructure elements and applications by using pipelines. And we had like a test environment, an acceptance environment, a prod environment. And depending on which environment things were pushed to, we wanted to have different people approve it. So for example, if it was sent to the prod, the testers had to approve it. If it was sent to the test, the developers had to approve it. So this way, we could have different approval flows. And we want the people to be able to just approve this in our pipeline. So we don't have to have a separate shadow IT administration next to it where people say, yes, it's okay. And only after that, somebody else presses okay. We just want to automate this as much as possible. And there's two nice ways of doing this. And the first one is using environments. In Azure DevOps, you can define different environments and you can link a specific type of job, a deployment job, to this environment. In a deployment job, you can still do anything you want. It's just called a deployment job. And in the environments, you can define different approvals and checks to use. One downside of using this method is that you can't define it in code, at least not at the moment. So these environments you have to set up in Azure DevOps, and these checks you have to set up. There is auditing on it. So if something changes, you can look back at what changed, but it's not in source control. And you have to make sure you set up the permissions differently for who's going to manage this. A different way of doing it is using a manual validation task. This is a task which at the moment is still in preview. And what you can do is you can give it a specific timeout if you want. So so it will only wait for a certain amount of minutes. This can be quite long. And you can say which users to notify. You should also be able to do specific groups, or you can, for example, use distribution list or whatever if you want to reach multiple people. This is defined in code. This is something you just put in your pipeline itself. So this way it's easier to manage. But there's a little bit less granularity. You have to put this manual validation task in every job which needs a validation instead of just defining an environment. And if you use the same environment 5 times, it will just know who to call to. Of course, you can use templates for this and make a validation template for your prod environment, for your test environment, and so on, and add this to your job. Um, And yeah, one nice thing is also after the timeout, you're actually able to determine what's going to happen. You can say after a timeout, it will just continue anyways, or it will stop working. So for example, if you put a timeout of a day and after a day, nobody approved it, you can say, well, continue anyways, because apparently everyone was too lazy. Or you can actually make it stop because nobody approved it. And now let's show it to you. So I've got two environments here. I've got the prod and the test. So in my test environment, there's no approvals or checks defined. While in the prod environment, I say there's approval and all users must approve. And I have a certain person who needs to approve this. I have my repository approval flows. And here I've got the whole pipeline. So we run it again on the hosted agent. And I've defined different stages. So first I have the stage test. And in test, I have a deployment job. So you see, this is the deployment job. And what it does is just a simple PowerShell script saying hello world. But we defined the environment. So this will run on the environment test, which has no approvals. Then I've got a stage called deployment prod. It depends on test. So test has to run first just to make it a little bit nicer in the end. And this will run on environment prod. So this needs to be approved by the checks set in the environment. Again, it will just run a simple PowerShell hello world script. And here we have the stage with the manual intervention, which also depends on test. So after test is done, these two will run. And here you see we use a normal job. I have to specify the pool server because it can only run in a serverless job or an agentless job, sorry. And you can define it this way. And here you see that I have the validation task defined. So somebody will get an email saying they need to validate it. And then I've got the second job that after the validation, I'm actually going to run this script. So if this validation fails for any reason, it won't execute this job. And if it does work, it will execute the job and continue. So this again, we can also run. So when I'm running this, I see this nice chart where I first have to deploy it on test, and then it's going to deploy on the different ways of having an approval. So the test will run very quickly because it only has to do in hello world. So we see it's done already, and it started the first one. And now it says both are still working. This one it's queued, so it's waiting. This one you see is running, but it's running on this manual intervention, and the manual intervention says it needs to be reviewed. So if we're going to my email, it says I have a manual intervention pending. I can also set up emails for the other one, but I believe I've disabled most of the notifications because I was spammed down while testing. So normally you would also get a email notification for this one. Now I've set it up in a way that I can't approve them all. Normally you would press the review and approve both of them in here. I have to do this from a separate window because else if I started it, it would automatically approve because I started it. So I'm going to quickly in a different window, press the approve while you are still looking at this window. And I've approved them now. So any moment we should see that they start running, and both of them ran. So this way I can create approvals. It is interesting to see that you see the deployment intervention. It actually ran for 1 minute and 41 seconds, while the other one ran for 7 seconds. So this job only starts once um, um, once it is approved, while this job keeps running until it's approved. This is also why it needs to be an agentless job, because else it would just put your agent. It will take up a spot on your agent and nothing else can run on the agent. So this is the approval flows. Let's go back to the presentation. Seems we're still good on time. And now let's talk about the big one, parallelization. When we're running big deployment jobs or big packaging jobs or whatever, it can be nice to parallelize things. Especially, for example, when we're doing testing on an application and we need to test on different platforms and so on, it can be very nice to be able to run these things in parallel. If you want to do things in parallel, you need to buy this at Microsoft. Normally in the free tier, you have the option, you have one parallel job for the Microsoft hosted agents. And in the self-hosted agents, you have 3 parallel jobs. So you can purchase more of them. And for the Microsoft hosted agents, I believe they're $40. And for the self-hosted agents, it's $15. And this is per month. So this is something as a company you need to decide if you think it's worth it or not. If you're using the self-hosted agents and you set up the parallel jobs, like you see here, you still need to make sure that there's actually agents to run it, because one agent can still only run one job. So on a self-hosted agent, you can just define the same agent 3 times. You can select 3 different folders and set up the agent 3 times on the same virtual machine, for example. This way you can have 3 jobs running at this virtual machine at the same time. You can also use containerization and so on if you want to make it a little bit more fancy. But essentially, you can set up a VM in Azure, install the agent 3 times, which is literally downloading a zip file from Azure and running a PowerShell command where you have to press a few times or enter a few values. To use parallelization, one of the first things we want to use is the depends on uh, attribute from a job. So here on the right, you see I've defined 2 jobs, random1 and random2. And both of them just pick a random number and they store it in a variable. So you see here the right host task set variable. This is a way in Azure DevOps to store a variable. And by using the depends on, I can determine which job is going to run when. If you don't use depends on at all, Azure DevOps will normally just run every job in series. In the same stage you saw before, I have this job defined, which is called print. And print depends on 5 other jobs. So you just saw 2 of those. I have 5 in total. So this means that print can run after these 5 have run. The other 5 don't have a depends on at all. So if you set up your jobs this way, Azure DevOps knows that it can run random 1, 2, 3, 4, and 5 in parallel. Now you see something about the variables because I often want to get these values from these jobs. I need to define the variables. And this is where I also come in what I said earlier with templates. I need to know how often I will call it and how many different things I need to run. So if I have like um, an output from a different program, which can be somewhere between 1 and 10 things, this way won't work. We're going to look at a way to do this later, unless I just make a maximum amount and have some of them just be null. A different way of using parallelization, or it's actually kind of the same way, but a nicer way of writing it, is using the matrix. In a job, you can define a strategy, and in the strategy, you can define a matrix, and the matrix holds the different jobs you need to run. So here you see it says num1 with an output var of random1. Technically, just having num1, num2, num3, num4, num5 would be enough. What Azure DevOps does is it creates a copy of this job with the name in the matrix appended to the name of the job. So you would get job random num1, random num2, and so on. In the variables, which I define here, to give an example, I now use the output var. Technically, this shouldn't be needed because it's still different jobs, so I should be able to still get the output from it. But I wanted to show that below the name of the job, you can actually define different variables for these jobs. So I've defined the variable output var for every of the jobs, which has a certain value. And it's just able to get these values. Um, Yes. And now onto the big one. Because a matrix is very nice, because the matrix, um, when it creates the jobs, it actually does this in runtime. So where in the first example, we had to define them all in our YAML already. And here I also still define them in my YAML. I can actually have a job before it, which is called create list. And in this create list, I can have a PowerShell script creating a stringified JSON object containing the different jobs and variables in these jobs to use. And then in the strategy, I can use a runtime expression to get these values. So I'm saying runtime expression, which sounds very fancy, but what does it mean? When we're looking on the line of the right host, am I still using a variable here? No, I'm not. Oh, let's go back to this one. On the last line, you see there's a dollar bracket output var closing bracket. And this is just a normal way of using a variable. This is done when the task starts. So when the task is executed, it will replace all these values with the values of the variables. Here on the line where it says matrix, you see a dollar and then a block bracket. I'm not sure if that's the right name, but I think you understand what I mean. And then it says dependencies.create list.output and so on, and a closing block bracket. This is a runtime expression. So this is actually executed on runtime. So once it encounters it and needs it, it will be processed. This way I can have this variable which is defined in the job before actually be used in here. And you see here I do 1 to 5 and then create an object out of it. I could easily change this to 10 and then we have 10 different random numbers. Now there is a slight problem because if I don't know exactly how many jobs I will create, I also don't know exactly which variables to get. So in the example where I used all of them and just defined them, I can say at the end the variables and just define them all from the different outputs. But if I don't know how many there are, I can't define these variables. So it's hard to eventually also use the values from all these different random things, all these different parallelized jobs in one job at the end. If you don't have to do this, it's very easy. If you do need to do this, you can, for example, use an Azure storage queue to store all of the values in and at your last job, get everything out of the storage queue again. So I'm doing this in the example we're going to look at for in a moment. And at the end, I want to have my storage queue removed. So next time it be generated again. So I know for sure nothing is left over. And I want to make sure this always happens. If you want to make sure things always happen, you can add a condition always to it. This way, even if other jobs fail or in the stage, this job will still run. This job will just always run. Now, if this job fails, of course, it won't work, but normally just deleting a storage queue shouldn't fail. And I could even include a retry we saw before in case it failed because of Azure being down or the API being a bit weird. And this way I can create a resilient pipeline. Now let's see if we can make this demo also work. So we're going to the parallel processing one. So let's quickly look at the pipeline. So I have 3 different stages. I have the parallel with jobs where I have all of them defined by hand and then together. I have the one with the matrix. So you see it's getting, it's in less lines already. It's easier to read instead of having all these lines. And then at the end, I have the one with the generated one. So here I also generate a storage queue. I create a list. These 2 things can be done in parallel. Then I have the matrix, which is called from my PowerShell script. It does it. Instead of putting the variable of values in a variable, I put them in a storage queue. And then in the end, I get all the values from the storage queue and print them. And every time I get a value from the storage queue, I delete it from the storage queue, and I just do a do while loop until it empty out the whole storage queue. And at the end, I delete the storage queue. I'm just going to show you how it looks after I've run it, because running this will still take 2-3 minutes. So I've run it before just to show you how it will look. So here you see the get random number, which we defined by hand, and a random number is generated. It does this 5 times, and at the end, it prints all my random numbers. This was the one with the matrix, so it almost looks the same. You see that the num1, num2, num3, and so on are appended to it. Again, it just generates a random number. At the end, the numbers are printed again. And here's the other one. I have a storage queue created. In here, I've created the list. And then here we see the num1, num2, num3, num4, and so on again. And the numbers are printed again. And at the end, the storage queue is deleted. So these are different ways of parallelization. With different pros and cons. I mean, the last one, it's very nice, but it's also very complex. So if you don't need it, I wouldn't advise using it this way. But I've been in situations where I wanted to use this and wasn't able to do this yet. And now finally I know how to do it. So last tip I want to give to you is how to implement automatic rollback into your Azure DevOps pipelines. Because it's very nice if you're deploying like resources to Azure, but even if you have like your test, your development, your acceptance environments, and so on, still sometimes things can go wrong. Often your prod environment and your test environment are not completely the same. Maybe some data is different. Maybe the test environment is just specced out a little smaller, and in the prod environment, things still go wrong. So you have to do a rollback. Now, doing rollbacks with source control is not that hard already. You can often just run the same pipeline from a commit ago. But you still have to do this manually. So somebody has to look at the deployment to see if it works or not. And if it fails, fix it. Especially if you're deploying like different steps, different resources, which all work together, and you've made changes in different levels. And the first few changes go by okay, and then one of the changes fails, it could create a downtime, and you need to roll back then. So I will show you how a way of doing this automatically. We can do this by using deployment jobs. Deployment jobs, they have different levels of deployment. In the strategy, you see here it says pre-deployment, and there's different options. There's the pre-deploy, the route traffic, post-route traffic, and on. And on is a nice one because on has two situations, on success and on failure. So what I'm doing in this pipeline is when the pipeline is successful, I store the commit ID in this case, an Azure Key Vault. So I can easily retrieve it later. This can be in anything you want. And when it fails, so if one of the deployments fail, I trigger a build. And the pipeline I've created has the option to check in the Azure Key Vault for the commit ID, and if needed, takes this commit ID instead, and then deploys it from this commit ID. Triggering a build, I just use a trigger build task I got from the marketplace. You can also do this by the API if you want to, if you don't want to use marketplace things. And let's go on to the last demo. We're still good on time, so that's great. There will actually be some time left for questions. So while I'm going to explain it, I'm going to start this deployment already. So what's happening in the deploy with rollback is I've actually defined some parameters for this pipeline. So if you're running this pipeline, you can give some parameters. The resource group name was just a nice thing to show that you can actually have some parameters. And I have the parameter use last known good configuration, which normally is on false. It has a default value, both of them. So that way I could still just click and start it without having to fill in anything. This pipeline also uses the deployment variables, which is a variable group which is linked to the Azure Key Vault. So if I go to the library, in here I have a password because I'm going to deploy a virtual machine. So this is the password used in a virtual machine. And I have a last known good configuration. And this contains the ID, the last successful deploy. So it first creates a resource group, then it creates a virtual machine. And before it does that, it does a build step. And in the build step, we create an artifact. Because especially if you're going to do deployments with different stages, which often also have approvals, it can be that your pipeline could easily take like 1 or 2 days if there needs to be some checks and deployment and approvals in between. In these 2 days, things could have been changed. So at the start of the pipeline, we create a package, an artifact of the repository at that stage. So during the rest of the pipeline, we will always use this specific point in time. So even if things changed in the master or the main branch, it wouldn't affect our pipeline because we've got a point in time. Now here I'm using a condition and I check if this parameter is set on true. If it's not set on true, it will skip this task. And what this task does is it will use a git command, git reset hard to the last known good configuration ID. So I first done a checkout and I've defined a fetch depth of 100. So if my last known good configuration was more than 100 commits ago, this would fail. If your last known good configuration is more than 100 commits ago in your main branch, you might need to reconsider how you're doing your source control. And this way I can actually change the files I have on the agent to a different commit ID. And then because we're creating this artifact of it, after this, I don't have to worry about it anymore. What I'm doing here is I get the commit ID I actually used, because especially if it's not using this step, I do need to store it later. So it's stored in a variable here already. So later on, I can store it in the key vault. Then we have our deploy. I'm using a pre-deploy and a deploy step. In the pre-deploy, I deploy the resource group, and in the deploy step, I do the virtual machine. So if we're going to Azure, by now we should probably see a resource group called, we should probably see it if the pipeline was successful. It's still deploying the resource group. This is why I started it before. So this is taking longer than expected. This is what I mean with you don't need to be in a hurry if you're demoing with pipelines. Luckily, I've also made screenshots, so I'm going to explain the rest by the screenshots, and maybe later I can also show you how it looked. So after the whole job is done, in Azure, we will see the test resource group with a virtual machine in it. And what I'm doing afterwards is in the parameter file, I'm just changing this virtual machine size to something which isn't accepted. So somebody made a change to my deployment and it doesn't work anymore. Once it's not working, it will do a failure and you see the on failure being activated. On the previous one, we had the deploy resource on success. So it was actually stored in the key vault. Now it's doing the on failure and it's doing a trigger build. In my pipelines, I will see that the pipeline I started is the second one. You see it failed. And then a new pipeline is started afterwards, which used my last known good configuration and actually fixes my Azure deploy again. And that's kind of the end of my presentation and the tips and tricks I have to share with you. So follow me on Twitter. I have a blog and I will try to, before next week, have all the files I showed to you also on GitHub. I need to check them one last time for confidential information and so on. And I will also try to have the sheets included with it. So keep an eye out for my GitHub. And I think I will also be able to post it as a comment later in the meetup if it's online. Thank you very much for listening and questions.
Of course, first a round of applause. So you already had the applause. Yeah, it was a really great session. I've really seen some things that you know is possible, but just looking at how you have done it and worked your way around Azure DevOps itself and the pipelines was really great to see as well. We got some comments in from LinkedIn and YouTube as well. People saying that people are just still writing the pipelines in JSON. So it really depends on what you're doing, of course. And also a comment from Ivo. He really likes the rollback functionality ID. And that's basically also what I meant. It's a real cool idea to do with your pipelines and how to work around it. Really getting your commits that are working applied on the platform as well. And I think it was a really clear session completely because we do not really see any technical questions. So I think you have explained everything very thoroughly as well.
I hope so. I hope it was that and not that nobody just understood anything of it.
No, I think everyone just understood it perfectly. That's the good concept. So we also got a question from Ronald. Is it being recorded? Yes, for the people that are looking on it on LinkedIn now, We are also streaming on YouTube. YouTube will automatically publish the video. So the video will be online there automatically. So it will be, after we end the broadcast, it will be uploaded there directly. So you can view it on there as well.
I see something from Manbeer Piet now.
Yeah, let me show
Um,
you that one. It's a new one.
yeah,
The annoying thing is you now see a shift in Azure deployment towards everything in a bicep file, but I feel like you are missing out on the stuff with that approach.
I don't think so because I now used ARM templates, but they were just part of a job, and I can easily just change this to bicep. It was mostly I wanted to make a quick demo, so I just copied the ARM templates literally from the portal. But I see no reason why you shouldn't be able to do this with bicep. It's still also just taking the files from your repository and running it in a job in your pipeline.
Yeah, I think so as well. But I think Manbearpreet is meaning something different with his question slash remark. I think what he meant at this moment is that Edge deployments are now more set to bicep, completely to bicep files only. And I think you're missing out on stuff. Really depends on. I think he's mentioning PowerShell things or other things that you could do. Not sure here. I'm not sure if Manbearpreet is still online and maybe can add some additional comments. Uh,
Yeah, or maybe he's just remissing the JSON part.
we have another, yeah, but you will have to split the resource across the bicep file. That's not completely true. Maybe you can include many resources in one bicep file, and also you can also do other things around there as well. Do you maybe have a suggestion, Leo?
And I also showed that you have like this pre-deploy and deploy thing, but there's still multiple steps under it. So you can still have like in the deploy step, 4 or 5 different times you run the bicep. And if one of them fails, it will still go to the on failure.
Yeah.
It's just that you can split these a little bit. So you can even have, if for example, the pre-deploy failed, you could do something different than if the deploy failed. And you can read this.
Okay. And I will see a comment that he will be stalking you on Twitter. So
Yeah, he does.
so he will be helped. But I think there are a lot of options, and it all depends on basically how you want to deploy your environments and what
Yes.
the specific requirements are there. So thanks again, Leo, for doing this session for us. It was a really interesting one.
Yep.
Maybe hope to see you in an in-person session in the future as well. So
Yep.
thanks again, Leo.
Thank you very much for having me.
No problem. That leaves me basically with one last thing that I want to share with you. So we are still planning upcoming sessions for the cloud takeaways. So we have a CFP open on the internet. So if you would like to give a session, just let us know by filling out the CFP. We will check if you can come to our sessions. We also have an in-person one open as well. So if you want to be there, want to give a good presentation about any cloud technology that there is, just let us know. And for everyone else, I hope to see you next time. And thanks again, Leo.
Thank you.